Hello and welcome back. In this video we will continue with this chapter. So we just saw the product rule to see how to take the derivative of a function times another. Now we'll look at the quotient rule, which is to see how we take the derivative of a function divided by another function. And this does get a little bit messy, so hold on. What we get is another fraction. And the bottom of the fraction is the easiest to remember. It's going to be this function squared. And that's it. The top of the fraction is what's the messiest. And what I'll do is I'll try to do this in order. So we take the bottom of the function times the derivative of the top. And we're going to subtract the top of the fraction times the derivative of the bottom. So we've got g times the derivative of f minus f times the derivative of g, all divided by the bottom squared. So let's take the derivative of this guy. I've just got a single term on top and a single term on bottom. And let's use the quotient rule first and see how this goes. So if I want to take the derivative of this guy, x to the 7th over x to the 3rd power. This is going to be, we've got our fraction. It's going to be the bottom times the derivative of the top minus the top times the derivative of the bottom all over the bottom squared. And these are pretty straightforward derivatives to take in here. So I've got x cubed. The derivative of x to the 7th power is going to be 7 times x to the 6th power. Subtract x to the 7th power times the derivative of this guy, and this is going to be 3 times x squared, all over the bottom squared. So taking a power to a power, I'm going to multiply. So x cubed times x cubed is going to be x to the 6th power. And here we'll start to simplify some things. So the top on this left-hand side, I've got 7 times x to the 9th power. And over here, I've got a 3 times x to the 9th power, all over x to the 6th. Simplifying the top, I get 4 x to the 9th power over x to the 6th. And canceling out some of these guys, I get 4 times x to the 3rd power. So I did a lot of work, a lot of algebra, and we got here. Well, that's all well and good, but maybe you saw right away x to the 7th divided by x to the 3rd should just be x to the 4th power. So let's find the derivative that way. If I want to take the derivative of x to the 7th divided by x to the 3rd, well, x to the 7th divided by x to the 3rd, this is just the derivative of x to the 4th power, which after I pull down the power and raise it to the 1 fewer power, I get the same thing. So this is sort of a nice check to see that, yeah, the quotient rule is working as intended. And again, here, I can use the quotient rule and go through all these steps, or if I can simplify this, I might as well just simplify it first and save myself the trouble. Let's look at another function. So here, this one might not be able to be simplified right away, so we might have to use the quotient rule. So if I want to find the derivative of x squared plus 1 over 2x plus 3, I've got myself a huge fraction here. So again, let's start with the bottom. I've got an x squared, sorry, a 2x plus 3 quantity squared. And then the top of the fraction, I always start with the bottom times the derivative of the top. And we're going to subtract the top times the derivative of the bottom. So let's start simplifying. I've got my 2x plus 3, and I want to take the derivative of x squared plus 1. So I'll just take the derivative of both of them, add them together. The derivative of x squared is 2x. The derivative of 1 is 0. We're going to subtract this term times the derivative of 2x plus 3. The derivative of 2x is going to be 2 times the derivative of x, which is 1. So derivative of 2x is just 2. And the derivative of 3, which is a constant, is just going to be 0. And down here, I'm going to leave this as 2x plus 3 squared. I think it's a little bit nicer in the long run. And if we start simplifying the top, well, my zeros, I don't need those zeros in there. So on the left-hand side, I'll take 2x times 2x, which is going to be 4x squared. 2x times 3 is going to be 3x. Over here, I'm going to subtract x squared times 2. And I'll subtract 2 as well. All divided by 2x plus 3 quantity squared. Simplifying a little bit more, 4x squared minus 2x squared, well, that's 2x squared, plus 6x minus 2 all over this guy. At the moment, I think this will be almost as simple as I can make it. I could, for instance, pull a 2 out of the top. So this is going to be 2 times x squared plus 3x minus 1 all over 2x plus 3 quantity squared. The top up here won't factor. There's nothing that multiplies together to get -1 that adds up to plus 3. So this is as simple as I can make it. And that's all there really is to the quotient rule. Let's do one more example just to make sure that we have this down. We've got the cube root of x minus 1 divided by the square root of x minus 1. So maybe we can see if this will simplify at the end. But I don't know. I actually haven't worked this problem ahead of time, so we'll find out together. Take the derivative of the cube root of x minus 1 over the square root of x minus 1. And one thing I want to point out is that the cube root of x, well, this is just x to the 1/3 power, and the square root of x, this is just x to the 1/2 power. So I'm going to write it like this because it'll be easier for me to take some product rule, some power rules derivatives in there. So first things first, I'll take the square of the bottom. So this is x to the 1/2 minus 1 quantity squared. And then again, we always start with the bottom times the derivative of the top. Minus the top times the derivative of the bottom. Oops. I need to write the derivative of the bottom, not just the bottom of the fraction. Cool. So we have, again, top times the derivative of the bottom minus, I've already made a mistake, the bottom times the derivative of the top minus the top times the derivative of the bottom. It's very easy to get that confused. I just always have that formula handy. It's important. It would be important to memorize that as well. You'll make fewer mistakes if you have it down pat. So let's start taking some derivatives. You've still got 1 over x squared minus, the square root of x minus 1 times the derivative of this guy. So the derivative of x to the 1/3 power, this is going to be 1/3 times x to the 1/3 minus 2, minus 1. So that's going to be what, negative 2/3? Some scratch work off to the side. minus the derivative of 1. And the derivative of 1 is just 0. And then we'll take x to the 1/3 minus 1 times the derivative of the square root of x. So I bring down the 1/2 and I raise it to the 1 less power. 1 fewer than 1/2 is negative 1/2 minus, well, the square root, or sorry, the derivative of 1 is just 0. This is all over the bottom squared. So far, so good. Nothing too crazy. And then when it comes to simplifying, well, we'll see how much we can do. Clearly, if I subtract 0 from something, it's not going to change it. So let's take this first guy times this guy. So we'll still have that factor of 1/3. And then 1/2 times minus 2/3. Well, 1/2 is going to be 3/6. And 2/3 is going to be 4/6. So 1/2 minus 2/3 is going to be x to the minus 1/6 power. Okay, we're going to subtract 1 times this guy, so it's going to be 1/3 x to the 2/3 power. And now we're going to subtract this guy over here, so I'm just going to leave that minus sign there. 1/3 times 1/2 x to the negative 1/2. Again, the factor of 1/2 sticks around. And x to the 1/3 times x to the negative 1/2. So 1/3 is going to be the same as 2/6. So 2/6 minus 3/6. Well, that's x to the negative 1/6. So we'll have some things that will be able to add up. And then this last guy is going to be minus 1/2 x to the minus 1/2 power, all over the bottom again, squared, can't forget the squared, and then here a few things will cancel, but that'll be it. So what you'll notice is that we have some like terms, this first guy and this guy, but they're being subtracted. So 1/3 minus 1/2 is negative 1/6. And then we've got this guy, which is to the negative 2/3. And then we've got this guy, but the negative signs will cancel out. So we'll add 1/2 x to the minus 1/2 all over the bottom. And we could go through and simplify this some more. So for instance, I could multiply the top and bottom of this fraction by, let's say, x. And that would get rid of all of the negative exponents. But I think I'm just going to leave this here. The important point of all of this is in just setting this up from the get-go. Taking the bottom times the derivative of the top minus the top times the derivative of the bottom. Once you have that pattern down, the rest of it is just simplification using the rules of derivation that, the rules of differentiation that we have already seen.